In this video, we'll talk about initial value and rate of change as it applies to functions. So let's talk first about initial values. So initial value is almost exactly what it sounds like. It's the question of where does my function start? And there's a little bit of a gray area here as to what start means. So the idea is, if we're looking at an axis or a coordinate grid where you have your x and your y, we're looking at what happens when x is 0. So basically we're looking at where is my function, where does it cross this line. If it's up here at, let's say, 3, then that would be my initial value. Now the idea is, when x equals 0, or sometimes, as the case may be, it might be when time equals 0. It's whatever my function value starts with by default. So now that we've kind of talked about initial value, that's kind of your starting point. Rate of change is kind of a way to describe where it's going if we're talking about a function. So the idea of rate of change, it's a ratio. And basically we use what's called an m usually to denote it. So rate of change is equal to the change in y, and that's what that delta symbol means, over the change in x. So my change in height divided by my change in my horizontal motion, basically. So if I'm looking at, say, a graph, the idea is I'm going to look at 2 points, and I'm going to ask myself, okay, how much did it change horizontally? There's my change in x. And how much did it change vertically? There's my change in y. And then I'm going to take those numbers and plug them into this, expression, and that will give me my value for rate of change. It basically is a measure of how it's changing. We're describing how this thing is evolving using a single number. And we'll do an example to kind of illustrate both of these. So let's say I had these points plotted. And the idea is I'm trying to figure out the initial value and the rate of change, which we'll denote with IV and M, respectively. So the initial value is not too tough. I'm already looking at it here. When x is 0, y is 2. So my initial value is 2. That's where I start. Now we're having to look at rate of change. So looks like x is increasing by 1 each time. Okay, and then likewise, y is increasing by, looks like, 4 each time. So then my change would be these numbers. This is my change in x, this is my change in y, which means that my m is going to equal 4 divided by 1, which is just 4. So ultimately, my rate of change is 4. That's just one example. And the thing with rate of change is it might not always be the same exact number each time. This was just kind of a simpler example to illustrate the point of what we're talking about here. We're looking at how the function is changing as it progresses. And the idea is you look at, okay, from one value to the next, how did it change in terms of addition or subtraction? And you can have a negative initial value, you can have a negative slope or rate of change. All of these things are possible, and this is just one example to kind of illustrate the point. Now you can also do this with t-charts, you can do this with graphs, equations. You can look at these things, but the idea is you look at these points, you look at how it's changing as you go along, and that's rate of change.